All right, hello everyone. We're going to be going over section 2.3, which is more on solving linear equations. We have 4 objectives. Our first objective being that we want to learn and use the 4 steps for solving a linear equation. Objective 2 being to solve equations that have no solution or infinitely many solutions. Objective 3, solve equations with fractions or decimals as coefficients. And objective 4, write expressions for 2 related unknown quantities. So in our last 2 sections, we learned about the addition property of equality and the multiplication property of equality. So now we're going to be applying both of these properties to our problems or our linear equations. And what we see here with our new linear equations is that we may be able to, or we may have to apply both. So we can apply both properties in any problem now. So the objective 1, we want to learn and use the 4 steps of solving a linear equation. And here are going to be the 4 steps. And for the rest of this lecture, we're going to follow these steps when doing problems. So step 1, we want to simplify each side separately. So we want to solve each side of the equality symbol. So we want to use the distributive property whenever we need to. We want to clear parentheses, so we want to get rid of parentheses. So simplifying anything that involves parentheses. We want to clear any fractions or decimals. If we have any fractions or decimals, we want to turn those into whole numbers. And we want to combine all of our like terms. Then for step 2, we want to isolate the variable terms on one side. So we want to use the addition property of equality so that all terms with variables are on one side of the equation and all constants are on the other side of the equation. Step 3, we want to isolate the variable. We want to use the multiplication property of equality to obtain an equation that has just the variable with the coefficient of 1 on its side. Then step 4, we want to check. Then we want to substitute the value found in the original equation. If a true statement results, we write the solution set, and if not, we want to rework the problem. So this whole going through solving a problem and then checking is the same thing that we really did in the last few sections. We're just now assigning steps. We're assigning these steps and we're labeling them. So it's going to be a little bit more methodical now. And we just remember that our end goal for solving equations is to solve for the variable. We're solving for the variable, we're solving for x in most cases, even though the variable may not always be x. So our end goal or our final answer should look like x is equal to a or a is equal to x. Just a quick caution, we did go over this in one of our last discussions, but if you missed it, we just want to share that in an expression such as 8a minus 3 plus 2a, the minus sign can act like a factor of -1 and affects the sign of every term within parentheses. So if we have something like 8a minus parentheses of 3 plus 2a, it's the same as saying 8a plus -1 times 3 plus 2a. So we'd end up distributing a -1 in that case. So we can think of it in those terms as well. And then that would change both signs in this case. So our final answer would end up being 8a minus 3 minus 2a. So it does change those terms. So just be careful of that when doing problems. Objective 2, we want to solve equations that have no solution or infinitely many solutions. So equations that we've seen so far have only had one solution, and they're called conditional equations. And they're called this since they're only true under certain conditions. So every time we have solved a problem in the past, we always get something like x equals 3, x equals -5, x equals this, something like that. We haven't dealt with a problem yet that had many solutions or no solution. But let's go ahead and try some out. So we want to solve the equations and determine if they have no solution or if they have infinitely many solutions. So with part A, we have, for example, part A, we have 2 times x minus 3 is equal to 2x minus 6. Well, we want to go through and we want to solve this in the steps that we just learned. So using our step 1, which was to clear out any parentheses, use our distributive property, clear out fractions, and combine our like terms separately on each side of the equality symbol, that is. So we're going to use our distributive property to distribute our 2 times x minus 3. So this becomes 2 times x minus 2 times 3, which is equal to 2x minus 6. Our expression on the right is already simplified or in its most simplest form. Then we just want to calculate. So 2 times x will be 2x, and 2 times 3 will be 6. So what we already see here is we have 2x minus 6 is equal to 2x minus 6. Now we want to combine our variables to one side. We want to isolate variables to just one side. So let's go ahead and subtract 2x from both sides. So if we have 2x minus 6 minus 2x is equal to 2x minus 6 minus 2x. And what this is going to happen, or what's going to make this happen, is we have 2x minus 2x. Well, that's going to be 0x. So we're going to get 0 minus 6 is equal to 2x minus 6 minus 2x. So another 2x minus 2x. And this will once again give us 0 minus 6. Well, 0 minus 6 is just going to be negative 6 is equal to negative 6. And, well, with our next step, we would be putting our constants all to one side. So in this case, we're going to be adding 6 to both sides. But notice that there is no variable here now. We just have a constant equal to a constant. So when we go to our step 3 and we put our constants to one side, for example, we can say, well, let's put the negative 6 on the right-hand side, and we want to add 6 to both sides in order to get rid of it on our left-hand side. This is just going to give us 0 is equal to 0. And once we have some answer in the form of a number equaling the same number, so in this case, we could have stopped at negative 6 equals 6, or in this case, 0 equals 0. Whenever we get to this point where there is no variable anymore, this tells us that there are infinitely many solutions. We could plug in any number for x, and these statements would be true because they are equal to each other. So there's no need to check because our variable doesn't really have to equal anything. It could equal anything. So in our final answer, we're going to say the solution set is all real numbers. And this just tells us that we could plug in any number, any real number, and this statement is going to end up being true. Let's go ahead and do part B. Let's move it over a little bit so we have a little bit more room. So for part B, we're going to do the same thing. So let's start with our step 1. We want to clear out any parentheses, fractions, use our distributive property. So let's go ahead and do that. Combine like terms as well. So we have a 3 times x plus 1, and it's a minus 3x, which is the same as saying 4x plus negative 3 times x plus 1. This is equal to x plus 13. So let's go ahead and use our distributive property. This is going to give us 4x plus negative 3 times x plus negative 3 times 1. Is still equal to x plus 13. And now we just want to use our multiplication, or multiply out our terms. So we'll get 4x plus a negative 3x plus negative 3. And this is equal to x plus 13. And now we see we have 4x plus negative 3x. We have the same variable and it has the same exponent, so we can combine our like terms. So in this case, since it's 4x, technically minus 3x, this is just going to leave us with x minus 3 is equal to x plus 13. Our plus negative 3 we can just turn into x minus 3 now. So we finished our step 1. We have simplified expressions on either side of our equality symbol. So now in step 2, we want to bring our variables to one side. So let's go ahead and subtract an x from both sides to, let's say, bring the x's to the left-hand side. So now we'll have x minus 3 minus x is equal to x plus 13 minus x. So simplifying this, we have x minus x. Well, that's going to be 0x. So once again, we have 0 minus 3 is equal to x plus 13 minus x. So an x minus x, which is this was 0x, or 0 plus 13. So similar to when we had all real numbers, but what we see here is that we end up with a negative 3 is equal to 13. And now we can choose to stop here. We can go on to step 3 to move negative 3 to say the right-hand side. We can add 3 to both sides. That gives us 0 is equal to 16. But in this case, we can just stop here. Once we see that, once again, there is no variable, once we see there is no variable left anymore, and our numbers do not equal each other. So in our last problem, we had negative 6 is equal to negative 6 or 0 is equal to 0. In this case, we have negative 3 is equal to 13. So we have differing numbers on either side of our equality symbol with no variable. And this tells us that no matter any number we plug in for x, this equality statement will never be true. So this means that our final answer is going to be no solution, which we can actually represent as what's called the null set or the empty set. And we'll detail this in another second, but it looks like a circle with a slash or a backslash through it. And this signifies the empty set or the set of no numbers. So this tells us that there is no solution. So just highlighting the details of these last two problems, when we get the identity a equal to a, or some constant equal to the same constant, we write the solution set as all real numbers. We write our curly braces, and in between we write all real numbers. A contradiction is an equation that has no solution. So our part B in example 1 in this case was a contradiction because there was no real solution. So that's why its solution set was the empty set or the null set, which is symbolized as an O with a backslash through it. A word of caution, it says example 6, we want to say example 1. We don't write the set of 0 as the solution set of the equation, example 1b. So because there was no solution, we don't write 0, because 0 is technically a solution. So we can't write the set of 0 because that would mean that x could equal 0, and which we saw it can't. There's no value that we can plug in for x that would make those statements true, which tells us that we have to write either the null set or the empty set or something like that. Or if there are infinitely many solutions, we also can't just write that one value. So this would apply to actually example 1a and b. So if we do find an actual solution to a problem that can have any solution or all real numbers, we have to detail that it's all real numbers, because it can be 6. Also, when we write the null set or the symbol for the empty set, we don't write it in curly braces. We just leave it as a symbol on its own. So as a summary of our solution sets of equations, we have our types of equation, our conditional equations, which tells us that x is equal to a number, which means it has one single solution. So our solution set will just be the curly braces with the one number inside. Our other type of equation would be our identity equation, or a true statement with no variable, like 0 is equal to 0, and this means that there's infinitely many solutions, and our solution set is curly braces, all real numbers. Then in our contradiction equation, we have a final equation and a solution with no variable, such as 3 is equal to 4. So we have our differing numbers with no variables. And this means that we have no solutions, and our solution set is just the empty set, no curly braces.